Hello! It is February 5th, 2023, Sunday night, and we are going to do some live coding tonight. I hope you're doing well, and yeah, let me know if you're in the chat and you can hear me. That's the most important thing. And if you can see me, and yeah, that's about like if you could see the screen when I change here. Is this? As long as you can see those three things, we're good to go. Hello, how are you, Taif? We got Sardor in chat. Welcome. Hello, how are you? Yes, you can hear me and see me. Nice. Can you hear the music? Is the music too loud, too quiet? I have music on. Everything is good. Nice. We got people in the Twitch chat. Just in case you have never joined us before on this, we do have Twitch, which is the most fun place to hang out and watch. Let me make sure I have the right link. I'm going to put that here into the chat. If you want to go join us there, that's cool. It's working. You can smell me. Fruit can smell me. That's how good this microphone is. You can actually smell me through it. Man, did I shower? It's going to be a problem. You're going to have to turn that off. Turn that smell gauge down. Came from YouTube. Videos are very informative. Thank you, Night Coder. I like that name, Night, with N-I-T-E. It sounds cool. Is a Twitch chat different? Well, no. It's a little better, but it's not that much different. I would like us all to be in one spot, but really, honestly, I need to add some more like overlays and stuff from Twitch that appear on the screen like that. See that? When you follow me on Twitch, we get a little bit of that going on. Little Carlton dance. Okay, let's get to it. This is the competition we had been looking into last Sunday, and we're going to jump back into it. So it's a Kaggle competition. If you don't remember the background of this, there's this crazy observatory in the on the South Pole that just has all these sensors that are trying to measure neutrinos direction. We want to know the direction of the neutrinos. It's very important for us to understand the galaxy. That's about as far as I know with it, but that's how it works. So we need to know how neutrinos, what the direction that they're pointing, that they're moving. And the way they do this is they have these devices they drill into the ground. They measure the neutrinos, which, by the way, are particles that are hard to measure. So it's a tough thing to do. It's tough to measure the direction that these things are going. So they're giving us a bunch of data, which is basically time series values related to these sensors and when they fire off and say that there's a neutrino going through them. All your videos will be available on YouTube. That's correct, KV. Twitch community, people are different. I agree. We're a little different over there. All right, the data we've already looked over, but there are a bunch of Parquet files. It's just tons of data. By tons, I mean 117 gigabytes, which when unzipped locally is a lot more. So if I go into my input directory here, let's make sure I get this sized right. Yeah. And we go into my input directory. Here is the IceCube neutrinos. It's 199 gigs here locally, but when we open up these files, like these train files, they end up being a lot bigger. So let's just show you IPython, import pandas as PD. Whoa, it's auto-completing. Is it auto-completing from Copilot somehow? I don't know how it would autocomplete from Copilot. All right, so I'm reading in one of these files. The shape of it is 3 million rows. And if we do the memory usage of it, I think if I do info, it'll tell me the memory usage. Memory usage is 844 gigs. I think I'm in batch 1. So let's look at this. Batch 1 is 165 megabytes on disk, but when we open it up into memory, it's 844. So that's Parquet files just compressing the data. Shiv, welcome from India. How's it going? MMD's online. Hey, what's up? Welcome back. So that's just something to keep in mind, that this data is much larger than, even though we have what we said was 200 gigabytes. When you unzip or you open everything up, it's like much larger than that. So keep that in mind. And this is even like smartly formatted, where we have this charge value or sensor ID is at int 16. So it's not like they're taking up a lot of memory for no reason. Like auxiliary is a Boolean value. So if I do df auxiliary, will it tell me just the info of that column? Info on this. Yeah, 281 megabytes just in true and false values. So pretty crazy. A lot of data, basically. We did some analysis of this before, but the big thing that happened was we had this open sharing, or they had this open sharing deadline, which just passed. Early sharing prize. So I wonder if they've given it to... I wonder if they've given it here. Hey, what's up? Stay in chat. Hope you're doing well. Early sharing prize thread. Did they announce anything? So the early sharing prize was for anyone who shared a good scoring code base early in the competition, with a deadline being a few days ago. And people have shared it. And this guy, Rasmus, hope I'm saying that right. He shared his submission, which is one of the best public notebooks out there for this competition. So if I turn on this dark mode, we can see it uses GraphNet. And tonight we're going to dig into GraphNet and try to understand how it works. Maybe we'll get there, maybe we won't. But if you look at GraphNet, one of the main contributors, I believe, is the person who shared it, or at least the person in the paper. Where was I looking before? Here's the documentation. So this is a pretty crazy, it's got a lot of going on in this. So we're going to have to figure out how to run this locally and see how well that does. We have someone from Colombia. Skyrider, what's up? How's it going? All right, so we are going to go through his notebook. Let's share that into the chat if you guys want to follow along with me. This is the notebook I'm using, and I've downloaded it locally. And I'm going to close this and start working in here. So this is the GraphNet submission notebook, but just running locally. Now, one thing that we need to note is that there's a bunch of data tagged here that he has added. So this batch 1 dB, batch 5 1 dB in DyneEdge, I guess is a pre-trained model for this type of thing. And then GraphNet, which is the model architecture that we're going to be using for this competition. Now, it's a graph neural network, so it's a graph neural network accounts for all the data points, but then also the relationships. So the nodes being these data points, these measurement points, and the edges being the relationship between them. We are working, we're working on this Kaggle competition. Why don't I link this actual competition too? So you guys have it. But we're going to just try to see if we can get the code working locally. So we might need to download this, which I haven't done yet. So let's go here, batch 1, batch 51, DynEdge pre-trained, GraphNet and dependencies. Now these we should be able to install locally. So I'm going to create my own Oh, weird. So this is a data set. This is a code base that takes from other data sets. I think. Hey, HHT, welcome. Oh, thank you for subscribing. That's nice of you. All right, I'm going to spin the wheel for you. It's what we do every time that I get a new subscriber on Twitch. It's just what I've always done. And it always lands on this. Kevin! All right, yelled that as loud as I can. We're ready to go here. We're going to jump into GraphNet. So let me go ahead and go back here. Look at these dependencies and try to figure out what's going on here. If anyone wants to help, that's fine. So the input contains private data sources, which is annoying. And then this output has all these different versions. And then this software folder where GraphNet is in it. And then also some dependencies. That's a lot of dependencies. We're going to create our own Conda environment that'll take care of this. But let's go ahead and download this data also. So there should usually be a Kaggle URL or link that I can run to download this. This is 2.3 gigabytes of this database. So it looks like what they do in this is they somehow use an SQLite database to manage all the reading and writing of files. So we're going to have to download this. I guess I'll just download it this way. 529 megabytes zipped. And then we'll download this batch 51. So I think these are just the batch files converted into SQLite databases, which if I understand it, the code from what I read earlier, that's part of what it's doing for the test set. Moving to Twitch, see you there. Nice. Kevin! Here's the icon from downloaded. What icon? Herbie Hoover's here. Nice. So I downloaded that, and then I'm going to download this, even though I don't want to install it that way. So download output from this. That's going to be called results zip. I don't know why. And then I'm going to go into my input directory. We're going to wait until all three of these are done downloading here at the bottom. And once they are, I'm going to move them into this directory, and I'm going to unzip them. Hi, Mohammed. What's up? And then I'm thinking that our approach will be to create a Conda environment. So maybe I should get started on that. Conda create. Name is going to be GraphNet. Oh, let's wait. It's still downloading. Great when I do Kaggle stuff. Yeah, I feel like it's a little harder to actually show progress as we're going because Kaggle stuff is usually pretty slow moving, at least in my experience. Like you're not going to make huge breakthroughs just in a few hours. Do I prefer Jupyter Lab versus the VS Code Jupyter editor? Does anyone have opinions on that? So I've been trying to force myself to use the VS Code version for these streams, but I do have an affinity for the old school Jupyter Lab environments. I don't know. It just seems like it feels a little different when I'm moving between cells and when I'm converting between code and markdown cells. Man, this downloading is freezing up. I don't know why this would freeze. Oh, is my disk, am I running out of disk space? Yeah, my local directory is almost full. So let's open and let's move this over here. That's why. Let's delete some stuff. Maybe I can look at my downloads. There's got to be some stuff here I can just delete. Here's a few gigs of stuff. Move that to the trash. Go to my trash can. Great, now I have 11 gigs to work with. See how our downloading's going now. Still frozen? What would cause Chrome to... Maybe I just need to restart Chrome. Try to restart this. All right, almost there. Where's my history? There we go. Okay, so what did I download? Archive 2, and then the other one I don't think was finished downloading. So let's move downloads archive star here. Let's move all that. Let's unzip archive. That's this batch 1 database. And then I also need to look in, well, that's unzipping. All right, so now we have batch 1. Let's make a directory called batch 1 and move this in. And then remove this archive.zip. Let's unzip archive 1. Then we're going to make a directory called batch 51. We're going to move this database file into batch 51. Remove archive 1, unzip archive 2. This is the DyneEdge pre-trained batch 1 to 50. Why did they? Okay, so it's just, here's the state dict We should be able to open that up in PyTorch just to see what some of the details are on that dictionary. But I'm guessing they pre-trained to 50 batches. Maybe there's a post. Did this person post? Yeah, we should probably read this. Hello, everyone. GraphNet is an open source Python framework, Area 51, aimed at providing high quality, user friendly, end to end functionality to perform reconstruction tasks at neutrino telescopes using graph neural networks. That's what we're doing now here. In a recent paper, how a GNN implemented in GraphNet performs on a series of reconstruction tasks in IceCube. So they actually published a paper on IceCube data already. We've created an example notebook that contains everything you'll need to install GraphNet and train/apply this model to the competition data. Since the code is public, you should have every opportunity to tinker with the library, the graph neural network, or to implement a completely different solution using GraphNet. Okay. The notebook contains pre-trained version of the GNN shown in the paper with a similar training configuration, which has been trained on batches 1 to 50. Oh, I'm getting confused here because when I think of batches, I think of that your data's small enough that you actually... I was thinking like epoch or epochs that it trained on, but this is just the first 50 batches. That's why we have batch 1 DB file and a batch 51. But so this was only trained on the first 50 batches, and this data set has, yeah, many, many more batches to train on. The notebook is available here. We submitted this pre-trained model to the leaderboard using this notebook as GraphNet baseline. The submission is not a prize contender. Okay, so batches get swatches or something? Yeah. What are we doing? We're trying to predict neutrinos, Davis. Here's a competition link. Read up on it. Read up. Come back in a few minutes. Ask me some questions. We're learning about GraphNet. Having a bit is this the first or most upvoted post? Having a baseline is great. Early sharing prize was also a great idea. Was having second thoughts about... I don't know why data source was having second thoughts about sharing or not a solution. It will for sure be overrun with only 2 weeks into the competition. But 2 first weeks probably is not enough time to build a solid alternatives to existing solutions. Probable ESP winner just first to semi-implement this same baseline shared. You're totally right. The Dynet baseline was pretty solid. I have a long list of things that tried that didn't work. So this is, they're talking about how in the leaderboard right now, the person who released, actually, instead of looking at leaderboard, let's look at the publicly available code. Sorted by best score. The GraphNet baseline submission scored 1.018. And I thought this was named DyneEdge because data source is a dinosaur, but I think that's just the name of this architecture. DyneEdge scored 1.046. So I guess if they're going head to head for this early competition prize, GraphNet won, but these guys at GraphNet have been working on this for years probably to make this library that they created. Thank you. I actually skimmed through it because your first video. Nice. I'm working on creating an audio classification. YamNet, I want your opinion on how to make the end-to-end application to showcase my skills. That's a good question for the Discord. So, hey, Ander, welcome. How's it going? Discord will get you the link if you're in Twitch. If you're on YouTube, I'm going to paste this for you guys. What's up? Reading the 10 minutes to pandas right now and understand stack/unstack. Ooh, man, my brain can't jump between explaining that and GraphNet. Maybe next stream. Maybe next stream. But okay, so let's get into this solution. Let's see if we can implement this ourselves. So they're talking about, let's just go off of GraphNet now. Let's go off of the, we know this was trained on the first 50 batches, what they submitted. We should at least be able to run the inference code locally. We recommend installing GraphNet in a separate environment using Python virtual environment or Anaconda. Okay, we're going to do that. What version Python should we install? Conda create name GraphNet Python equals 3.8 is pretty solid these days, right? Yes, let's create the space environment. All right, so what is IceTray? You might want GraphNet to be able to interface with IceTray. Example, when converting L3 files to an intermediate style format for training GNN models. Examples, SQLite or Parquet. When running GNN inference as part of an IceTray chain. In these cases, you need to install GraphNet in a Python runtime that has IceTray installed. Does anyone know what 3.10 minimum? That can break stuff. So IceTray, Python. Do we know what IceTray is? The dump module prints. Am I crazy for not knowing what IceTray is? IceCube. IceTray is what I just emptied in the freezer. Hey, you're still doing that by hand? Don't you have like an automatic one that empties the IceTray? History lesson. Do we want to read a history lesson of IceTray? Okay, so maybe we want to install it with IceTray. Install without torch. Install with torch. Installing standalone. Let's see if his version he installed here in this notebook. We paid extra for an ice maker that lasts freezer. It doesn't have to last in the plumbing is. Yeah, ours at ice maker. Man. IceTray, if I understand, is the neural network. That doesn't make total sense to me, but let's see if they... So here they're not installing IceTray, but there is stuff with... There is stuff with Parquet files. And there is stuff with SQLite. Maybe let's just go with the standalone version for now. Yeah, we could also run it in Docker. Let's run a standalone version. Git clone my username. All right, so we're going to go into here. Kaggle, IceCube. Let's make a directory called GraphNet. And let's clone this. My username. I don't think I want my username. I think I want just this Git file. Right? Then it says the CD into GraphNet. Oh, they want me to fork it. I see what they're saying. Let's go up one directory and move this. And then move GraphNet's folder here so we don't have nested folders. And then we're going to CD into GraphNet. Got that? And then we're going to create our GraphNet environment. Oh, look, they already tell us how to create it. We should conda remove GraphNet so that we don't have an existing one. Conda remove environment. I always forget how to do this. Okay, so it's conda remove -n GraphNet --all. Yeah, that'll remove it. Well, I was wondering what a graph neural networks. I found this great website. Oh yeah, this is great. Yeah, nodes and edges. It's all nodes and edges. The first time I worked on a graph neural network was with, let me look at my competition history. My profile, competitions, man, I've gone down to 180th. And completed. We used them in trends. Oh, we used 3D neural networks in that. But this one, 3 years ago, predicting molecular properties. Because in molecular data, you also can use graph neural networks. Like if you look at the discussion here, most votes. I used a lot of GNNs, or I read a lot of them. A densely connected GNN. This is Dieter's solution. So there are a lot of graph neural networks for this. How much money do you make with Kaggle competitions, if you don't mind me asking? I don't make really any money with Kaggle competitions. I just do it for fun. If you're going into Kaggle competitions with the goal of making money, you're in the wrong business. Well, I mean, I guess some people, but it's hard. All right, so conda activate. Hold on. I only removed the old one. Yeah, so what I've found is that, yeah, Kaggle competitions open a lot of doors for you. They'll help you learn a lot of stuff, help you get better at your skills. But if you're just trying to compete, there's so many really good people out there competing for the top prizes that and there's always a little bit of uncertainty and luck involved. So to really like spend 3 months working on something, assuming that you're just going to get the prize money would be tough. Yeah, they have prize money. So like even the prize money that I've won, if you're splitting it amongst teammates and you're taxed pretty heavily on it, yeah, it's almost like a gamble. So yeah, this is the sort of stuff that's really fun about doing Kaggle competitions on stream, is that we're waiting for this Conda environment to install. I mean, of course I could have done this before stream, but then what's the fun of it? While this is loading, let's look up. Let's look up the Torch GPU version of what it's going to install. So it's going to install PyTorch stable 1.11. It's going to install Torch cluster, Torch scatter, Torch sparse, and Torch geometric. Now, if we go to this Kaggle notebook of the submission we're trying to recreate, I believe these are all the things that were installed here at the beginning. So manually installing these dependencies and then installing GraphNet, the Torch version, and appending the working directory to GraphNet to include GraphNet. So that makes sense. So we're kind of doing this part of the notebook right now, so we can run this locally. We might see some of these errors when it's installing. Oh, well, I guess we haven't even started to install the requirements yet. Make ChatGPT use Torch. It probably does. Probably already does. I got an interesting question. Were you competing in a team or solo? If you had both experience, I would like to know what are the pros and cons of both ways, team and solo. So solo, in order to become a competition grandmaster, you must achieve a gold medal on Kaggle solo, at least one. Working solo can be great. It's like all great or all horrible. It's horrible. It's great if you can actually do well and then you feel like, hey, I've done this myself and no one else had their hand in it. I don't have to ask any questions when I make any changes or picking our last submissions. I just get to choose and go. But I'd say it's much more enjoyable and much more of a learning experience when you team up with other people. So these are some of the teams that I've worked with. This is the University of Liverpool ion switching competition, is the one that I got a gold medal working alone. I was driving myself crazy for months just thinking about this problem, not being able to ask anyone else questions or like knowing if I was the only one, going crazy about it. But I would say the downsides to working with the team are partially that like you can team up with people and they're not putting as much effort into it as you are, which can be frustrating, or there's like communication blocks and you have to make, you kind of have to work together, collaborate, which can make it a little bit harder sometimes. But actually, aside from all of that, from my perspective, I felt like the times when I didn't want a team or I wasn't happy with teaming with other people was because I wasn't putting in enough effort. Like, I feel like when I worked on these competitions, I wanted to like give it all, my all. And some of the competitions I teamed with people and I was like, just to let you know, I'm not that into this one. I'm not going to be spending all nights and weekends on it. And then I felt like, even then, I felt like I wasn't, you know, living up to my expectations in it. So that would be a downside to teaming. But I'd say if you're early on in competing and you can find some people who are equally as excited about it as you, try to join a team because it's definitely worth it. My big takeaway is teaming up is totally worth it. All right, so now I'm in my GraphNet environment and I'm installing the requirements. So all these requirements from up here: PyTorch stable, torch cluster, torch scatter, and torch sparse. This is super cool. Thanks so much. Absolutely. Interesting to hear insights and opinions. Yeah. Yeah, I think the early days of Kaggle for me, when I teamed up with people, were some of the most fun times I've had working on projects by far. Like, just learning from other people, really smart people. Like, look at all these teams that I was on. And a lot of times when you do well, or when you actually get used to working in these competitions, you start off solo for a long time. Like, you work for most of the competition by yourself, and then you only team up with people towards the end if you think you need it. If you think you need to like team to get better. Which laptop am I using? I'm using my desktop that I built myself. It does have GPU support. I've got let me show you this way. Got two 1080 Ti's. Kind of old GPUs, but they do the job. Okay, so what can we do here in the meantime? In the meantime, and in between time, let's actually look at this solution. So let's edit my copy of the solution and try to understand what's going on. My new desktop doesn't have a GPU and doesn't have a slot for one. How does a desktop not have a slot for a GPU? Am I crazy here? All right, so we're not going to install all this stuff here. I actually wondering how long this would take here. Might have to do all this. Okay. So let's see what they're doing here. They have this load input function, excuse me. And it pulls in this batch ID. So we provided a batch, a data frame, and an input data folder, which is a string. It reads the Parquet file, which is the detector readings. Where's this geometry table coming from? So that's just a straight up CSV that's been, yeah, that's the, like the sensor's location. And then I'm assuming this is going to be merged for column and sensor position columns, if column not in detector reading columns. Sensor positions column equals detector reading columns. Why write it like that? Why not just do a merge? I don't know what this, we're going to have to work that through. Detector readings equals, I'm running out of space on my disk. Yeah, no space left on my device for installing. Let's go and see what are some of these big Anaconda environments. It's so easy to fill up your 109 gigs. Conda EMV Conda remove -n. Let's remove stable diffusion. All. Still got a lot of to remove. Let's remove TensorFlow 1. I don't know when's the last time I used that one. Let's remove Birdclef. That was a while ago. This is like Rob cleans up his Conda environment stream. I need to find some other space. Where can I move? So it's most of these MKV files that are big. When I stream, I like keep the recording, and that can be a really bad thing for saving space. So let's go to media. Actually, mount Mulla, my disk. CD YouTube backups. Let's make a directory called stream backups 2022 and move all these start at MKV files here. Just another hard drive. Yeah, I'm going to move them all here. Are you more into PyTorch or TensorFlow, or do you use both? I've used both. I'd say if you're going to start now, that PyTorch is definitely winning out. It seems like most things are implemented PyTorch these days. Oh, shoot. I just realized move start at MKVs into stream backups. Yeah, move document. Yeah, then let's do this again here. Now we're starting to get some more space, a few gigabytes on here. So Conda activate GraphNet. And we are going to Go back into here, GraphNet, and run that command they said to run it on their page. GPU support version. See how it runs this time. Hopefully it'll have stuff cached so it doesn't have... Rob, did you check out Open Assistant? What's Open Assistant again? Remind me. PyTorch is more into research journals, right? And TensorFlow for normal people? Yeah, I guess so. That might be a good way to say it. I mean, most of the stuff I've done with deep learning is for Kaggle related. So I guess you would say that's research related. But really just like anything, if you're trying to run the latest stable diffusion or anything off a Hugging Face, I think it's going to be PyTorch models. I think PyTorch is kind of really strong in that area. So this should allow you to run scripts and examples out of the box. A standalone installation requires specifying a supported Python version, ensuring that C++ compilers are up to date, and possibly installing CUDA toolkit. So how do we test? We should be able to run these ice tray examples. We should be able to run this GraphNet. Oh, they use PyTorch Lightning too. Okay, so everything's installed. Everything is installed. Now let's see if we can go into these examples and run this train model. Probably should make sure my GPU that it's using is okay. It's having a problem with initializing my stuff with weights and biases, but I don't want to run weights and biases. Maybe I need to log into weights and biases. Weights and biases allows you to track your projects, and I haven't logged in a long time. So it's saying to go here and authorize. I should probably do this off screen to make sure. Sign in with Google. Gonna need like two-factor authentication. Copy this to clipboard, paste it here. All right, so I tried to write my weights and biases thing there. No, it's saying that didn't work. Just make sure I paste this is fine. Okay, if I paste it here, it should work. Pasting it, I swear. Copy. Pending our API key, so that's not the problem. Let's try this other version. Train without configs. IceCube is not available. Oh, so weights and biases can't log into this. Weights and biases directory, project and entity. Maybe it's because I don't have weights and biases configured. Prediction names, parse arguments, GPUs, batch size. Can I turn weights and biases off? Or just make weights and biases local? Logger equals weights and biases logger. So I think let's just comment this stuff out and see if it will run with this stuff commented out. I'm going to pass that one and remove this logger. Writing logs locally. Okay, so this looks good. So it is training. It is training. I just need to turn off that weights and biases stuff. And that means our Conda environment is good to go, people. Weights and bias offline. How do I put weights and biases offline? What do you mean? How do I turn it offline? Test your mom. What are you guys talking about? Open assistant is this. Are you promoting? Swapped. Are you promoting this? How do I do it? How do I do it? Sign in. Continue with Discord. I'm going to have to check this out later. What do you mean? Do I have to type weights and biases offline in command line and then it knows to do it offline? Oh, so okay, so let's try this. Let's exit out of this. So you're just saying do this. Weights and biases offline. Running your script from this directory will only write metadata locally. Okay. I like this. And then I can go back in here and remove all these things that I removed before. There we go. Move this. Move that. Let's see if it trains. See, weights and biases creates this directory. What if I tail this debug? Doesn't look like that debug has anything in it. Yeah, and then these are all my logs. All right, so this works. Looking good. Looking fine and dandy. We are able to train the GraphNet in this Conda environment. And let's go ahead and install pip install ipykernel. And then we're going to do Python install, no, GraphNet. So now we have GraphNet in here where I should be able to, let's see what it's going to do. GraphNet is here. I should be able to just comment this first stuff out because it doesn't need all this stuff installed. That's what we already did. I think we're going to have to install SQL Alchemy. IceCube is not available. Some functionality may be missing. Okay, we're fine with that, right? Git log. Logs are written to logs.graphnet. So now we're in the notebooks directory. Let's see, there's a logs, and we can tail this GraphNet. And now we have the same info and warning. Okay. We can remove Kaggle working test database. Is that going to be here? It isn't there, so we aren't removing anything. This is going to be just our input directory. This is going to be just our input directory. This is going to be our input directory. And this should be our, I guess our database is in our local directory, test database. All right, so it says can't remove this because there's no file. Let's just remove that anyways. All right, so now we have a database file here called test database that's going to store the Parquet files of our models. Let's see if this will even load this chunk of stuff. It will, even though it's saying GraphNet could not be resolved. That's just joking, I guess. Prepare data frame. So this is what we actually care about. I can't read this code without having this installed. Pip install mb black actually into conda activate GraphNet. Pip install mb black. This will make, at least for me, some of this a little bit more readable. Can we get the font size bumped a smidge? Yes, I can do that for you. A lot of this code is like wrapping multiple times, so it's making it hard for me to read even this small. But I think this is a lot of the main thing that it's doing. Prepare data frame. Where is that called? Prepare data frame is the main thing that it does. Okay, and then we have this config, which we're going to have to change. The local path of our test database is here. We probably should make this like a local and Kaggle version, like a config file diff that we can change just from Kaggle versus local. Before I've had it done it where it sees and what username is running the script, and if it's in Kaggle, it'll be just like the default username, not EC2 user, but something like that. And locally it'll be my name. So then I had the code, like you have the code, so when you're running it locally, it looks for certain directories, and when you're running it in the Kaggle notebook, it looks in different directories. Here it's saying, where is it failing? Load state dictionary. State dictionary path. This is hard coded in here. Load pre-trained model. Why are we going to hard code this in here, dude? Yeah, let's not do that. And then let's do this. and do state dict path is going to be ..dash input. Results equal inference.model.config. Cannot parse I need this. No such file or directories. Input dynet edge pre-trained. Okay, so this is because in here I need to make a directory called dyne-edge pre-trained. Or I could just change this. Or I could just make this look into this dyne-edge pre-trained batch. Blah, blah, blah. Predicting data loader, predicting. All right. So this created our results. So if we look at our test, and we're going to look at IceCube. No. This is trying to autocomplete for me, and it's not right. IceCube This is trying to... Google Copilot tries too hard. No, it's in... test meta.parquet. There we go. So this test data does just have 3 events, which is event ID 2092, 7344, and 9482. And we have the results from that. So it's running. It runs on my GPU. It predicts the output, but we still don't really understand how it works. So let's see how it works. Let's try to get a glimpse into how it works. Okay, so this prepared data frame is basically just taking the results from this results output and converting it into the format that the submission data frame wants it. So this is just like a post-processing step that Azimuth and Zenith, it's not necessarily something we need to worry ourselves with that much yet. I think this makes sense. But let's try to understand how the model stuff works. The big thing we want to do is understand what this dyne-edge model looks like. And we really want to understand how the data loaders work. So this makes a data loader. And that's part of GraphNet. Wow. So GraphNet training utils has everything that creates this data loader. And I never understood what are these features that it feeds in. So I'm going to move this to the top. Almost would be easier to run this. Not here. All right, so load input. Oh, it converts it to SQLite. Oh, so it's only working easily because it's only working out of the box because it's using this convert to convert to database, convert to SQLite method. So basically we're taking all of the test data, we're converting it to SQLite. And that's why it's working. So let's try, and maybe let's just walk through what this does. This converts a selection of the competition's Parquet files into a single SQLite database. Arguments: the metadata path, the batch size, the batch size, that's just how many loads at a time. Database path, that's locally, so that's this local test database.db. Then input data folder, these are where all the training data or test data Parquet files sit. Those are spherical coordinates. Okay. Accepted batch IDs. These are batch IDs you want converted. Defaults to none. So we should go into our source directory, or actually do it here. Let's go into our source directory, make a new file called GraphNet prep.py, and then we're gonna throw all this stuff in here. So these are all the methods and functions that take GraphNet and converts them into this local database version. Right? And then let's also add a if name equals main. We're just going to pass, I guess. And now I want to create another script that converts to SQLite. Yeah, let's do it in a notebook. So basically what I want to do is be able to run the inference. Is the code available to download? Yes, all available. It's all available. It's all taken from this notebook, basically. Trying to find this for you guys. Yeah, basically everything is coming from this GraphNet, and then also this notebook that we're using. So that's GraphNet. It's specifically for working with detecting neutrinos. And then this baseline submission is what we're trying to recreate on the test data. So we could try to run this on the test data. What are we going to try to do? We're going to try to run this. We're going to append our path with the source directory. And we're also going to make sure we're in GraphNet's environment. And we're going to say from GraphNet prep import. What is this called? Convert to SQLite. How do they run this? They ran it like this. So we're going to create a database with the training data set, right? So we have the training data set because we know it's been trained on batch 1 to 50. Let's predict on batch 50 to 100, and then we'll try to see if we'll use the scoring metric on the 50 to 100 predictions. Or maybe we'll just do, let's just do like one batch to start with. I don't know how long it's going to take. All right, so it's creating this log directory. Now we need this to be train. The geometry stays the same, and this is train meta. And then this is going to be called our train database. And also we want to do, what are other parameters here? Database path, batch size. I thought there was a accepted batch IDs. All right, so let's remember what the accepted batch IDs are going to be. They said it was trained on, what did he say in this discussion thread? I think it said somewhere trained from batch 1 to 51. So let's just do 52 to be safe. We're going to predict on batch 52. PD is not defined, of course. Always got to import pandas as PD. So it's saying unexpected keyword argument. I thought there was a batch, accepted batch IDs. So this is written in the arguments. It's written in the doc strings, but then it's not actually implemented in the code. Do you see this? It says it defaults to none, so it should be like this. Batch equals batch size. Iter batches, batch size. Can we query? We can't query on this. Metadata path. So what I'm trying to find out here is it's taking this metadata batch and then it's feeding it into this add to table. So metadata batch and metadata iter. I haven't worked with Parquet directly like this before, but let's try to test it out here. So let's just do import Parquet as PQ. Let's load this metadata path. Oh, from PyArrow. Is this right? Import PyArrow.Parquet as this. Batch size, let's make this 500. I don't know, just something to test it out with. And then in this code, what do? They take this and they iterate over it. And then they convert it to pandas. I don't know if anyone, I haven't been looking at the chat. Everyone might have left. I don't know if anyone cares about what I'm doing right now. It seems kind of boring and mundane, but if you're interested in what I'm doing right now, just let me know in the chat. That auto completion is insane. Yeah, it's Copilot, but it's good, but sometimes it's horrible. Okay, I'm actually accidentally iterating over all the batches. Just want to see what's going on here. What am I doing? I don't know, 5Shot. What am I doing? It would take me a long time to explain everything, but maybe someone in chat can give you the links. We're working on this Kaggle competition. Here's a link. Oh, freaking GraphNet. Kaggle neutrinos. We're trying to predict neutrinos. People are still there. Okay, so haven't gone completely crazy. So what it's done here is it's done this metadata batch. But what's metadata iter? I don't know if I like this. Let's change. This iter batches is kind of handy, but I want to be able to, I want to implement this accepted batch IDs, which they didn't actually implement, which we can't complain about because they did everything else, but we also have unique batch IDs. How's that used? That's not used anywhere. They're probably trying to figure that part out. So can I filter? Yeah, let's do this. Let's do metadata PD read parquet metadata path, and this will be our metadata df, right? Is the problem that this is too large? Even the metadata is too big. So maybe here on metadata batch, I can query where batch. Yeah, I think I know what I can do. This won't be the best way to do it, but if, look, it's auto-completing. If accepted batch IDs is not none, this is what I was going to write, then we'll make sure it's in. That's exactly what I was going to write. Thank you, Copilot. So then accepted batch IDs, when we run this, here is going to be just 52, and this needs to be a list. And we need to restart this. Contains multiple batch IDs. Did you set the batch size correctly? Load input metadata batch. This needs to be loc. Shouldn't we also say if the length of this is batch that we continue? Because we don't need to do anything if the size is 0. The size is nothing. Start this bad boy. Should just make this into a script. How many money per month? Copilot does cost money. It's like $100 a year. In Turkey, there's a huge earthquake. Uh-oh. Hope everyone's okay. A bunch of submissions seem to be leaning to the regressions, but I'm not entirely sold on the idea. Something makes me think a professional psychist would have seen that from the start and played with that. Leaning on the regressions. What do you mean, Jarvid? Oh, can I explain what the challenge is about? I have a YouTube video from last week, that a live stream, Jonathan, that you can go back and watch. And we talked about it for like a few hours. Geometry table is not defined. Oh yeah, that's the other thing. Why not make these things just pass through? I didn't understand why they didn't do that here anyways. All right, so we're going to make this a variable that we feed in here, which is a data frame. And then when we say load input, pass through this geometry table. And then we'll make this a required data frame to be provided. I'm doing type hints here because they did type hints. I'm not usually doing type hints in my code because I'm not that good. Hey, following your games. Thank you for subscribing. How long has it been? How long have you been with us? I know I've seen that name before. Oh, 1 month. They subscribed for 13 months. 13 months following your games? I think you've been with me from the very beginning. Thank you so much. Let's spin the wheel for you. Let's do a wheel spin. That is crazy. You've probably been watching since I was streaming chess. Nothing but the best for you. I'm going to type pizza in here another 10 times. I'll even do more for you. For 13 months. That's awesome. Kevin! Yeah, no Kevins. Thanks, following your games. I really do appreciate it. All right, so now this convert to SQL actually takes in that. And we should restart. We should make this a script. And now it shouldn't complain about geometry table not existing because we've read it in here. And we can make this like with an arg parser, but hey. All right, why is it complaining? Unique constraint failed. Meta table event ID. How is that possible? Is it because batches are split up? I think what it's trying to do is batch number 52 is split between two different chunks when I run it. So maybe that's why it's not letting me add it in. Then it deletes this metadata patch. Let's try to, maybe this test train database was already there and that's why we have to remove it each time. And let's actually try to run it on a few different batches, 52, 53, 54, 55. Let's give this a try. Put all this in one spot. Because we can see here in his code, he would remove this test database, which for us is train. I need to update Jupyter and IPy widgets. That's why we are not seeing a progress bar. Did you say unique constraint? So setup table, there couldn't be duplicates. Yeah, this database table, I'm guessing, has unique constraints. Yeah, well, index is false. Chunk size. Index column is event ID. So event ID should be unique. Is that right? Yeah, we need to look up SQLite's create table to understand this. Oh, it's actually utility in GraphNet. So if we go into GraphNet's here, GraphNet.data, the SQLite, where's this? Test that. We're in a different branch, GraphNet. The data, examples. Oh, this is GraphNet team. I'm not sure why I'm not seeing that. So, is it actually working when I run it here though? It looks like it is. We have no progress bar because I don't have TQDM installed correctly in this Conda environment. But we do have this. I've been moving all weekend. Happy to be done. Nice, Steve. Watching code stream in my new place on a new fancy TV. Oh, man, I shouldn't be on a TV. This isn't entertaining enough for that. It's in SQL Alchemy, I think. Oh, so is this like... it's like a nested import. Yeah. So SQL Alchemy create table. We need this Python, and we need this to be like that. Hold on a second. Is it SQLite that it imports from? This is still running on 4 batches. So we're looking good so far. It's SQLite utilities. So I don't know if this is necessarily this create table function that we're using, but if it's something like it, it creates a table. Oh, this just takes an SQL. I hate this nested stuff. SQLite. So if I go into data here, how is this working? GraphNet importing from data. Let's see where SQLite is referenced. Oh, here we go. Source GraphNet. Okay, so yeah, I was looking in the wrong spot. SQLite utilities. Here's where create table is going to be. It creates a table. Integer primary key not null. Create table. And then it has form this query string. And the query string is probably like a create table. Oh, well, it's already here. Create table, table name. Here are the columns. With foreign key on. And then it creates the column with the requirements integer primary key not null if it has integer primary key. Otherwise, it's not needs to be not null. And when we feed this in to our create table, integer primary key is the is primary key. When we feed that into here, it's just true. And this is if it's the index column, it does that. So then what is index column defaults to event number. But in our code, index column is event ID. There we go. We dug down and now I understand how it creates this SQLite database with a unique constraint on the event ID. And it's just grinding away right now. This is a pretty beautiful code that they wrote it to work in batches like that. And it can work on all this data and just kind of create it. So it takes about 5 minutes to run through one iteration. And it's about 2.9 gigabytes. I'm surprised that they're not running out of space when they do it. I'm surprised they don't need to predict in chunks. Because here, they're creating the whole test set as a test database. Which is pretty, yeah, seems like a lot. So for us, in theory, we should only need to do this once on all of the data and we should be good to go, right? Let's see what our logs are saying. While this is running, maybe we could go into this test version and see what this model looks like. So build model is done in here, but let's restart this and let's just check out the model. So we're going to create a new notebooks for exploring the GraphNet model. At least the one that they used in this. So what do they have here? They have load input, all this stuff we don't need for that part. These are our helpers for GraphNet, and maybe we should put this into a script here. In our source, new file, GraphNet helpers. Maybe call it something different later, but for now that'll work. If name equals main, we're just going to pass on that. It's run our black auto formatter so we can read this a little bit better. Yeah, and I think this should work now. And then we're going to import sys path, append this with our source directory, and then from GraphNet helpers, import build model. No module named PyTorch Lightning because we need to be in the GraphNet Conda environment. And dict is not defined. That's because it was probably imported. This is still going strong 10 minutes in. It's probably imported from like here. So let's see what parts of this we need. Probably don't need this, 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 or this. We can see they're grayed out. All right. And let's see how they built the model here in this. Now I'm getting lost. Where am I? Where was the, here's the baseline. Here's the model where the version where they actually do everything. And what they do in here is they inference takes a model and the configuration file. We just want to build the model with the configuration file and the training data loader. So we're going to load pre-trained model with this. We're going to see how it's done here. Here's our config. Oh yeah, we do this here. Now we're just going to import from this other place. Features does not exist. So where did features come from? Don't understand this features. Features is imported from, it's actually imported from GraphNet data constants. So they have, what is features? So deep core, wait, what the what? What the what? Data constants. Okay, so let's look up in their code base and see in their data. They have a constants. You're telling me there's a Kaggle constant. It does not exist here. How are we doing it then? GraphNet data constants, import features, truth. This is just a base class that should have Kaggle in it. What's the history on this? Last edited in October 2022. It's definitely the Kaggle. What? Someone explain that to me. What a nightmare. What are people saying? Aren't they reading the generator though? And it also seems in. Hey Rob, Rex, what's up, Rex? Just got in, likely that I can figure out what's going on from now. Probably not. Maybe a little bit. Just watch your video on data science environment on YouTube. Enjoyed and found it informative. Thanks, Rex. Appreciate that. What was the SQLite function? The SQLite function creates the database. Which one? What are you using the SQLite database for? So we're using something called GraphNet, which is a framework that's already been created for doing this specific task of predicting neutrino direction based on a graph neural network. Right? We get that? They have set up their architecture to read from MySQL databases. So the first step in the process here is to take the data as we have it in Parquet files and convert it into a SQLite database for easy reading from the, I'm assuming, data loader. But what is completely miffing me and confusing me is that they have these features and truth, which imports from GraphNet data.constants, and in it that's just like a base Python class that when I load it here has values for the Kaggle, the way the Kaggle data is set up. But when I look in the GraphNet repo in the constants directory, I don't see that. Am I in a different branch? No, I'm in the default branch. Here we go. Here we go. I was in the wrong branch. That's why I was going crazy. Okay. So they added Kaggle here. It's just like part of their code base that they have the format that Kaggle likes to put it has named the columns for the data. Let's click on blame here. We can see when that was changed. I know this is ugly looking, but the Kaggle was added 2 weeks ago. So they just added it to their library. And that's for the target. And yeah, this was added 2 weeks ago. Isn't GitHub great? All right, so now I've got that cleared up. Now we can load our... Why is it complaining still? Features is not defined? Sure is. Oh, are you telling me that features isn't fed through? So there's somewhere in this code. Make data loaders. Let's try restarting and just seeing. Hopefully that's just the only issue. No, it's still saying features is not defined. So there's somewhere in deep in their code base which has the features not passed through as an argument. It's in this make data loaders. Make data loaders. Oh yeah, see, it has features in here as like a default value. So this won't work. This kind of code won't work when you don't have features defined above it somewhere in your code base. So let's just take these features and target truth.kaggle. And let's make this like that. Default is going to be that. And the default of this is going to be like this. And we should be good to go. Restarting. Isn't Kaggle fun, guys? You think that Kaggle's fun? I mean, I enjoy this stuff, but it's just not stream material. I'm worried people won't like this on stream. This is what it's like. Features not defined, but I just changed that. So why is it still complaining? Oh, it's also here. Of course. It's hard coded in here. I mean, again, I can't complain. Why is it? Oh, this should just be config features, right? And this should be config target. Same thing here. Yeah, I think we're good. You vibe with it? Nice. Okay. So we're loading this model. Assert is instance list tuple. So the truth needs to be actually what's the type of this? It's a list. Oh, it's not called target, it's called truth. Truth social, guys. we're truth socialing this. You started Kaggle recently and you love it? Nice, I do too. There are times when you want to bang your head against the wall, but truth is not a list or tuple. Truth. Oh, there's a bunch of places where it says target. Yeah, truth. Let's just make sure there's no more. So there is something called target and there is something called truth. Difference between target and truth. Target is direction. Okay. Hopefully we got that figured out. Let's see if our GraphNet submission has run. Sorry, our yeah, so this is still running. It's still creating this database with just these 5 batches or 4 batches. And how big is it at this point? Train database. Oh, it looks like it's done. Train database is 9 gigabytes. And it last updated 2 minutes ago. So I don't know why this is still running. We'll check back on that. That's been running for 24 minutes. So we changed these helpers to not run off of that. And we're going to try this again. All right, now we have our model. It's a KNN graph builder with a leaky ReLU activation dyne edge. So what is the dyne edge backbone? Let's understand what that is. Model architecture. Our GNN implementation henceforth referred to as dyne edge is a general purpose reconstruction and classification algorithm that is applied directly to the event pulses from the IceCube detector. Therefore, the algorithm does not rely on the pulses to be aggregated into summary statistics. Instead, dyne edge uses graph learning to extract features from the pulses, making the mapping of measurements learnable. Additionally, dyne edge learns the optimal edges between nodes and can be applied to events with any number of pulses. That's nice. Dyne edge is implemented using GraphNet, a software framework for graph neural networks in neutrino telescopes. Okay, so GraphNet is a general framework for creating these graph neural networks for neutrino telescopes. And dyne edge is an implementation of it specifically for this facility, this IceCube facility. Following me? Oh no. Oh no. We're getting spammed. Just noticed that. How do I block that? Do I care? Port. Spam. Report. Hey, just people type stuff in the chat so that we get rid of all this spam stuff on the screen. Because it's gonna, I deleted it from the actual chat, but we need more texts here that'll just push it out of the way. There we go. Is this a Jupyter notebook? Who asked that? Yeah, it's a Jupyter notebook inside VS Code. Rob fell for the spam. All my base are belonging to them now. Like, who's just going to go to a website because of that? It's got to be something more than just spam. Because I can't believe anyone is just like watching my stream and then deciding, oh, you know, I'm going to go to that website because of like all 50 people here. Actually, there's 69 people watching right now. Funny enough. All right, so where were we? Additionally, dyne edge learns optimal edges between nodes and can be applied to events with any number of pulses. Dyne edge is implemented using GraphNet, a software framework for graph neutrino telescopes. Dyne edge uses convolutional operator EdgeConv, developed to act on point cloud graphs in computer vision segmentation analysis. For every node, with the node features, the operator convolves via local neighborhood. So the thing with the graph neural networks is if you think about the number of nodes that you have, and then if you want to consider every single edge between every possible node, the amount of edges gets very large very quickly. And then your whole like matrix is or tensor is absolutely huge. So instead, you only consider n nearest neighbors. And this is by distance, I'm assuming. So if we go back to our drawing of the device that we're working with in our exploratory data analysis, let's see if this will load up. All these different data points are coming in. And when we're building the graph neural network, it's only considering edges between n neighbors. And I wonder if that's a setting in here. It absolutely is. So when it's building this graph builder, it's only considering the 8 closest neighbors to create this graph. Why choose a graph neural network? So in this competition, they had an early competition prize, and whoever had the best score within the first 2 weeks got like $5,000. And the people that released their results used a graph neural network. All the people working in this field, like that, their whole life is devoted to it. Seems like they use graph neural networks. There are a bunch of papers out there about it saying it's state of the art. Hence, us looking into it. I know you're probably busy. Can leisurely guidance on building a ticket management system for your company. Love your channel. Thanks. Not right now, but if you join the Discord, ! Discord on Twitch. And that doesn't seem to be working. Oh, there it goes. Yeah, we can chat there. I'm glad you're liking the video. How about XGBoost? So that's the thing. XGBoost models are really good on tabular type of data. But when you have data like this, when you have data like this that's coming in with all these different points and everything's relative to each other, like the values are actually, it doesn't matter what this one dot's value is. What matters is what this one dot's value is related to all the ones around it. And I found this out in the NFL Big Data Bowl competition like 3 years ago. If you're trying, and in the molecular competition, if you're trying to build features that you can feed into an XGBoost model, and believe me, I did it. I think I had the highest scoring tabular solution to that molecular properties competition. I built a bunch of features, but you just can't build enough features to match the graph neural networks. XGBoost works great for like tabular structured data, but when you have to build features that basically engulf like every relationship, then it doesn't work. Like you mean auto-correlated data? I don't know about that. All right, so now we kind of know what this backbone is, but we still want to know what this architecture actually looks like. Okay, here we go. So we have our input graph. It has the edge convolutions, another edge convolution. So it's like 4 deep edge convolutions. This is the part of, so basically we have a framework now here where I think we could pretty easily train and predict this architecture on the data set that we have. Now the question is there some modification to this architecture that could be made that would actually make it produce better results? Or is it simply going to be training a lot on, because it's a lot of data? Is it just going to be running a bunch of GPUs like nonstop and then ensembling results? Or there might be some other clever solution someone comes up with that works well. So this is the architecture of their model. If we go back into Model Explorer, do we see this here? Actually, let's see where it actually builds the model, because that's a cool part. Standard model, we don't want that. I'm also interested in this graph builder, because that's kind of cool idea. KNN graph. And then where does IceCube Kaggle come from? Oh, so they even have an IceCube Kaggle. Wow. So this is like they've done a lot of work for us. And it's going to make it a lot easier. So in here, models. We have to go into source GraphNet. Models. So there's a model for creating the KNN graph builder. So this is graph builders. Builds a graph from the k nearest neighbors. So this is where it takes these nodes and converts them into... Sorry, it takes all the values at all the XY positions and then converts it into k nearest neighbors. And then creates a graph, and it uses this KNN graph from a built-in PyTorch. Everything in. So in order to know this, understand this, we'd have to go into Torch Geometric. I think I've seen this before. So Torch Geometric is basically a wrapper around this. Where is our GitHub? Torch Geometric NN. Let's find KNN. So basically we have like an infinite number of things that we can tweak from this model to try to make it better, not knowing really what will, but there's a lot of stuff we could do. I want to just see what this KNN graph looks like, this code looks like. So let's look at the source code. So it takes in a tensor. K is the number of neighbors. Batch. So this loop means it contains self loops. So that's like in the adjacency matrix if it has an edge that goes to the own. I'm not quite sure what that is. Cosine. We use a cosine distance instead of Euclidean distance to find the nearest neighbors. Oh, okay. Do you guys know what the difference is between cosine distance and Euclidean distance? Which software? Which software? What? Oh, we're using VS Code. So this does all the work. Torch cluster.knn graph. Why have a function that just uses another function? I'm sure there's a reason. I just don't understand that stuff. So what is torch cluster? Torch cluster extension of library highly optimized graph cluster algorithms for the use in PyTorch. This package consists of following clustering algorithms. So this is the KNN version. Let's see what this looks like. See how deep the rabbit hole goes? The confused face I made every day when I read other people's code. Yeah, you have to get good at it with this stuff. With Kaggle, you have to be able to interpret other people's code because no one's gonna build this from scratch. So let's do cosine distance versus Euclidean distance and see if there's an image. Oh, this is nice. Yeah, so cosine distance has to do more with the angle from a central point, and Euclidean's just like x minus y squared minus, x1 minus x2 squared minus y1 plus y1 minus y2 squared, and then the square root of that. Something like that. I don't know. We're not using Manhattan distance or Hamming distance here. But I think Euclidean distance makes sense here. It looks like it's the default. It also looks like a lot of this stuff is just default. So most of this just comes from torch cluster. So should we dig deep in and understand all this? Torch cluster, KNN. Oh, so it's using JIT. So it's like compiled torch code. This is the stuff that I'm so happy is done in an optimized fashion by someone else. Because I remember when we were doing these early competitions with graph-like data, you had to write this yourself or find someone's code on Kaggle that you could copy. So yeah. All right. What are we going to try to do? We're trying to see if this batch is actually done running. Conversion complete. Database available. So now we have a training data set which has 4 batches worth of data ready for consuming. Nom nom nom. Not like that, but all right, so we're gonna go over here into this. Let's rename this also so I don't get confused. So eventually, probably after the stream, I'm gonna run this code on my I'm basically gonna run all the training data through this and have it in the SQLite database format, which, by the way, let's see what size it is. I won't make you guys sit here and watch. But yeah, the train database stayed at 9 gigs. I wonder if it was done a lot earlier and I think it was just iterating over all those batches, which it wasn't even looking at. So we're going to try to run the inference on this. So let's go to this GraphNet baseline. Remember how they did the inference. So they just did this. Yeah. So I think we should be good like this. So we're loading their pre-trained weights, which they did train from batch 1 to 50, not to 51. We're loading in that state dictionary, and we're running our truth. We're living our truth social. No, let me close this. So we're going to look at... Not the EDA. Going to look at the model exploration and import things this way. Guess all this has to go here. Let's just put all this in the same cell. All right, so then we're going to run this on train database. Yeah, let's just hard code it for now. This should be good. Runtime name tag. GraphNet. Train batch 52 to 55, I think it was. Getting tired here. Okay, so what do we run? What do we run this on? Oh, it was in the same. Is it in the same notebook I was already in? It was here. We ran 52 to 55, and that's going to be what we'll do here. Batch size 200, number of workers 2. I probably could bump that up, but let's just do that. It's going to use my first GPU. Train selection. I don't know what that means. Inference is not. Where did inference come from? We need to import this from here probably. Predicting data loader. Whoa, it's going to take 25 minutes. I don't know if we want to sit here for 25 minutes. Let's see how the GPU's doing. GPU's maxed out. That's a good sign. We want the GPU to have all the memory used and all of it be fully maxed out, which means we probably can't speed that process up. A lot of times when your like data loaders is lagging, you'll see that it dip down when it's trying to load in each next batch, but this looks pretty clean. And that also means there's got to be a way to limit this inference. To just run on a single batch, maybe? So inference selection. So what does selection do? Make data loader selection. I need to dig into what this make data loader does. which is in GraphNet training.utils. We're going deep. We're going deep. Don't need to go here anymore. GraphNet training utils. Make data loader. Selection. This is optional. Selection. Oh, so that's the index from the database. What is string selection? I wish I knew what this string selection was. Doc strings would be nice. SQLite dataset takes in string selection. Let's go here. So I think if string selection is what it sounds like, the question is, does this inference here allow me to do a string selection? No, it doesn't. Make data loader does take in string selection. Okay, so let's just do this. Oh, it broke. CUDA out of memory. So that's not good. That means that it ran out of memory on my GPU and I need to make the batch size smaller. Its batch size is too big, but that's good though, kind of. I guess we could say it's kind of good. Because then we can just do this selection. Trying to understand how it works. Validate selection. It makes a training data loader, a validate loader, oh, so it doesn't even use the validate. And then this is the test data loader. So we can put this selection up here. And then we can put selection here. This says entire database if none. Maybe I should not make this selection pass through. This should be in the config. Right? So by default, this should be... it should be test selection. It should be test selection, which already exists. Because inference is done on the test selection. Let's just try to do it on one selected value. What's it saying? Output exceeds the side limit. Where did it fail? File. List index out of range. Hi, Rob. Hey, Jose, what's up? What computer are you running this on? I'm just running on my local machine. It's just my computer. Angle between vectors rather than absolute sum of the different. Oh, yeah, that was what we were talking about before. All right, so what am I thinking about right now? I'm thinking, how is this selection stuff fed through to get a subset of the data base? Because clearly this goes through this selection. In the make data loaders. Goes into here where we looked up in the code base, make data loader. This has selection, which is a list of integers. That's what I provided it, right? Thought I provided a list of integers. Then it uses this SQLite data set. So I need to go into data. SQLite data set. And then this query table has this query table a specific index, optionally with some selection. So this has its selection as a string. Oh, selection as a string? Okay, so that says, oh, okay, so then we could do what is saved in this database. So if I just pass in a string like batch ID equals 51. String selection resolve batch ID equals 51. Okay. Cannot assign without a target object. Giving me a headache. I need to understand how this database interaction works better than I do now. Maybe selection is a length data with a binary mask. I'm not quite sure how that works. Length of the data with a binary mask. But we can try this. I want to try if I just at least pass through this in. It should be the wait, what? String selection resolver. So that did not like it. Cannot assign to literal. I think I need to figure that out. But if I keep this as none, if we make our batch size slightly smaller and we can make this 16, restart this, check out how much memory is being used by this, not much, and then try to run this, we might be able to get this through in about a half an hour, which I will take a look at after the stream is over. I mean, later on this week, and see what the results look like. What I'm assuming, what I'm hoping is that the results look something in the same ballpark. If I run the metric on it, because I have the ground truth for batch 50s on, the metric would be somewhere in the range of what we see on the leaderboard. Now, so what we should be able to do is take this existing model, just take the weights that we have and train on 50 more batches and see if there's improvement. I would think there would be, just by training it on more batches. But we've been handed like everything that we need to do that. It's just a matter of understanding how their code works and making some tweaks to it. Because I'm just trying to, like, this stuff, I'm trying to figure out how it pulls from the database. Because I just want it to run basically on, like, I wanted to show you guys the results of 50 things instead of 50,000 or however many it's doing it on. 5,000. I would like to run it just on 50 of these so I could show you what the results were. But hey, you know, I need to dig into this code and figure out how it interacts with the database. And it looks like some stuff hasn't been fully implemented in their Kaggle version of it, but we could just pass through some parameters that could help us out. Hope that was helpful. This is what it takes to win these types of Kaggle well, I'm not even on the level of being able to win this, but to understand at least what a top level solution at this point in the competition has going for it is to understand this code. Now, the other approach would be to try to build this from scratch yourself, which is another option, but would probably take a lot longer. I don't know. Yeah, probably would take a lot longer because these people know what they're doing. And then once we fully understand it, we can try to like modify it and tweak it and train it more and see if there's any post-processing we can do or pre-processing we can do or metric optimization that we could do. There's a lot of options. But for tonight, I am done. This was a fun stream. I hope you guys had fun. Where do you find these challenges? They're all on Kaggle.com. Now, if you do ! Kaggle, you in Twitch, you will see my link to my Kaggle profile. If you do ! Discord, you will see my Discord link. If you do ! YouTube, well, actually, let's just do this. YouTube.com/@RobMulla. That's my YouTube. If you haven't followed me there, please give me subscribe. That would be great. And then we also have my Twitter account, which you can follow me on if you feel so obliged. Yeah, so there's my Twitter. And here's my YouTube. Would appreciate you guys following me in all those places. And I will see you next time. So I'm traveling early this week. I'm definitely not streaming on Tuesday, but hopefully we'll come back on Thursday and check out some more of this competition. And let's go ahead and raid someone in the coding software game development world. Search for Python. Chrissy Codes is doing a cozy Sunday coding. Someone's doing, do we want Chrissy Codes, or someone's doing something with stable diffusion. Love from India. Oh, thanks. Rosh, thanks, appreciate it. So the exclamation point Twitch, oh yeah, that doesn't work unless you're on Twitch. So I need to figure out how to change that up. But there's my link to my Twitch. Let's raid Chrissy Codes. Go to mine. Raid channel. Chrissy Codes. Start raid. So we got 10 seconds. Thanks everyone for hanging out. Be kind to each other. Love each other. And I will see you on Thursday on the stream, hopefully. Unless something else happens. All right, stay safe. Bye, everyone. See you, YouTube.